Question 11 over here is on quadratic inequalities and discriminant. So let's do 11a over here first. The question asks us to find the range of values of k for which the line y equals to kx plus 3 lies entirely below the curve xy plus 20 equals to 5y for all real values of x. So in this case, you can see that when the question tells you that the line y equals to kx plus 3 lies entirely below the curve, right? It means that the line and curve, they both do not intersect one another. Okay? So if they both do not intersect one another, then we have to use discriminant b squared minus 4ac less than 0. But before we get to that, right? Now let's do 11a. Okay? We are going to write two equations out. So the first equation will be y equals to kx plus 3. So we call this equation 1. And we write xy plus 20 equals to 5y. We call this equation 2. So what you have to do first is to substitute one of the equation into the other. So sub equation 1 into equation 2. We get x kx plus 3 plus 20 equals to 5kx plus 3. So let's simplify this. So this is kx squared plus 3x plus 20 equals to 5kx plus 15, which means let's group the terms all to the left. We get kx squared plus 3x minus 5kx plus 5 equals to 0. Okay? So we know that the curve do not intersect with the line, right? Since the curve and line do not intersect, b squared minus 4ac is less than 0. So what is my b? My b over here is actually, if I factor out x over here, then the b will actually be 3 minus 5k. So then this will be bracket 3 minus 5k whole thing square minus 4 a, which is k, and finally c, which is 5, and this is less than 0. So expanding this will give us 9 minus 30k plus 25k square minus 20k less than 0. So simplifying this, we get 25k square minus 50k plus 9, which is less than 0. Okay, so factorizing this, we get 5k minus 1, 5k minus 9, which is less than 0. So let me do a check. Yes, that's correct. So drawing a curve over here with, so what makes this 0 when k is 1 over 5? What makes this 0 when k is 9 over 5? So because we are looking at the portion of the curve that is less than 0, meaning below the x-axis, so this is the portion of the curve that we are looking at, which means that the range of values of k for which the line lies entirely below the curve, which means that both of them do not intersect, for all real values of x will be k is more than 1 over 5 and less than 9 over 5. So that's for 11A. Okay, so let's do 11B. Same thing, this is also on discriminant. The quadratic equation mx squared plus 5nx plus 9m equals to 0 has equal roots. Given that m and n are positive, find m over n. Okay, so for equal roots, b squared minus 4ac equals to 0. So my b is actually my 5n. So then b squared will be 5n whole thing square minus 4. My a is my m, and my c is my 9m. So this is equals to 0. Simplifying, we get 25n squared equals to 36m squared, which means m squared over n squared is equals to 25 over 36. So take the square root on both sides. We get that m over n equals to 5 over 6, or m over n equals to minus 5 over 6. Now we got to reject this. Now the reason is because the question already told us that m and n are both positive, so we have to reject this. Okay, so we are done finding m over n. Okay, so now the next thing the question asks us is to find the range of values of m over n for which the quadratic equation this time has real roots. Okay, so here we are actually doing it for the equal real roots, right? So now we have to do it for real roots. So instead of writing b squared minus 4ac equals to 0, we are going to write b squared minus 4ac more than or equals to 0, because this time we are looking at it where the quadratic equation has real roots. Okay, so this means that we are going to write back the same expression, the equation over here. Okay, so I'm not going to skip step, so let me write down again. So 5n whole thing square minus 4m 9m more than or equals to 0, which means that 25n square minus 36m square is more than or equals to 0. Okay, so what I'm going to do over here is I'm going to multiply both sides of the inequality by minus 1, which means I get 36m square minus 25n square is less than or equals to 0. Now factorizing this is 6m minus 5n, 6m plus 5n is less than or equals to 0. So here to here I actually use a square minus b square equals to a plus b, a minus b. Okay, so which means from this inequality over here, let's draw the graph again. Okay, so what makes this 0? Okay, when m is actually let's see, when m is actually 5 over 6, 5 over 6 n, correct. Now what makes this 0? When m is actually let me do it the other way. Okay, so what makes this 0? When m is actually minus 5 over 6n, okay, over here. And what makes this 0? When m is 5 over 6n, okay. So this means we have our inequality over here. M is more than or equal, because now we are looking at the portion of the curve below the x-axis, because this is less than or equals to 0. So over here, so which means m is more than or equals to minus 5 over 6n and less than or equals to 5 over 6n. And we know that n is actually positive, so we are going to divide the entire inequality by n. Now since n is positive, so we no need to swap the inequality sign. So dividing everything by n, I get minus 5 over 6 is less than or equals to m over n, which is less than or equals to 5 over 6. And note that we know that m and n are positive. Okay, so we can say that m over n, okay, is actually because m and n are both positive, right? So a positive divided by a positive, we get that m over n has to be strictly more than 0. Okay, which means the final inequality, the answer will be m over n strictly more than 0, but at the same time it will be less than or equals to 5 over 6. So that will be the answer for question number 11 on discriminant.